Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a good day. My name is Muhammad bin Hamdan and my metric number is A19EA0082 and I'm from group number 1 and my teammates are Muhammad HAIQAL, HIQMI bin ZAMRI, Ahmad SAFWAN bin ROSNAN NAHAR and finally Muhammad AMER SYAZWAN bin AZIM. And the question that I will share today is about question number 2. Alright, for question number 2, the question is data collected on a stretch of highway reveals that the free flow speed is 90 km per hour and the jam density is 112 vehicle per kilometer per lane and the observed maximum flow is 2000 vehicle per hour per lane. And the question A asks for the to establish the mathematical relationship between flow and speed for the given characteristics. B. Estimate the average speed and density when the flow is at the maximum theoretical flow. C. Estimate the maximum theoretical flow and why it is different from the observed volume. And finally, D. Estimate the average speed of vehicle if traffic flow is 1000 vehicle per hour. Alright, to solve question number A, it is asked to establish mathematical relationship between flow and speed. So from the question, we get the value of UF, which is 90 km per hour. KJ is 112 vehicle per kilometer per lane. Qmax observed is 2000 vehicle per hour per lane. So the equation that we will use is the equation of relationship between Q and U, which is the flow, and the speed, which is Q equal to U times Kj minus bracket of Kj over UF times U square. And then we just substitute the value of Kj, UF, and then we got the final answer, which is Q equal to 112 U minus 112 over 90 times U square. And then for the question B, it asks for average speed and density when the flow is at the maximum theoretical flow. So first of all, we need to find the theoretical flow, which is Qmax. And the formula is UF times Kj over 4. So we just calculate it, 90 times 112 over 4. We got 2520 vehicle per hour per lane. So we just substitute it in our equation that we got in question number A. 2520 equal to 112 U minus 56 over 45 times by U square. And then we will get the U value. It is 45 km per hour. So after we find speed, we have to calculate the density. So by the relationship between Q, U and K, we got this equation, which is K equal to Q over U. So we just divide 2520 divided by 45, and then we got the K value, which is 56 vehicle per kilometer. And then for the question C, it is asked to estimate maximum theoretical flow and why is it different from the observed volume. So like we calculate in question B just now, the max theoretical flow, theoretical by the formula of Qmax equal to UF times Kg over 4, we got 2520 vehicle per hour per lane. And for the max flow, which is Q max observed, just given from the question, which is 2000 vehicle per hour per lane. So why it is there are difference between theoretical flow and observed flow. The difference value between theoretical and observed maximum volume may due to human error while observing the car on the road when it's moving. So to overcome this problem, so we can do some precaution to make sure the max flow observed and the theoretical flow is same by make sure you have two people observe the same car. So we will reduce the error that may be made during the experiment. And then for the final question, For D, it is asked for estimate average speed, which is U, of vehicle if traffic flow. The Q is 1000 vehicle per hour. So same like question B we do just now. We just use the equation of Q equal to 112 U minus 112 over 90 times U square. So when Q is 1000 vehicle per hour, we just substitute the Q at the equation that we use in the up here, and then we got 1000 equal to 112 U minus 112 over 90 times U square. So we got two value from sorry two value of U from this equation because it is a quadratic equation. So we got U1 is 79.95 kilometer per hour and U2 is 10.05 kilometer per hour. We will use U1 as the average speed because U2 is a bit unlogical to this experiment because the velocity, oh sorry, the speed of 10 kilometer per hour is a bit too slow for the flow flow which is 1000. So and then that's all from me to elaborate about question 2, and thank you.